There are many different ways to solve subtraction problems, especially to elementary school students. Today we'll show you some of these strategies for subtraction problems in second, third, and fourth grade. The subtraction problem that we will be focusing on today is 401 minus 228. A second grader might want to use a model to find the answer to this subtraction problem. The student could use an open number line like this to start their thinking. Now, the number line will range from 200 to about 600, but for the purposes of this one, it ranges farther than that. But what you are focusing on is about 228, which is right here, and 401, which is right here. So 401 minus 228. A student could first do this by knowing to count back to 200. So they could start at 401, go back to 301, go down to 201. Then the student will say, what do I do with this 28 right here? Because we are at about 200 right now from the 201 point that the student is at. They will count down 28 spaces. If you go down 28 spaces, it lands about here, which is 173. So 401 minus 228 equals 173 based on this number line. So in the third grade, a student might want to try and estimate more than just try and solve the problem. So what I have here is base 10 blocks. This is another way that a student could show 401 minus 228. And even in the third grade, I feel like they could use these base 10 blocks. But what I'm going to show you is basically their thinking through their estimation and their derived facts before they start using standard algorithms and everything. So right here we have the 401, then we have the 201 and 28. I'm not the best at using this website. I think it's kind of confusing. So I'm just going to show you the best I can how it would be represented. So what a student could do is they could say that 401 minus this 200 leaves them with about 201. So what we're going to do is we're going to take away 400 and we're left with 229. So what we're going to do with this 229 is we got to turn it into our solution. So the next thing that the student would say is, let's take away this 28. So with the 201 minus 28, a student would be left with 173. This is the number that is the solution right here, this one right here. 173 is the solution. I'm not the best at representing it in these blocks, but what it would look like with these blocks. So 20, 40, no, 10, 20, 30, 40, 50, 60, 70, 1, 2, 3. So after subtracting that 28 from the 201 with the base 10 blocks, they would be left with 173. But with using these base 10 blocks in real life, they would need to be broken up instead of just doing it the way I just did it, which was using the program. But they would need to be broken up to show that 201 minus 28 is 173. That's only 73, so here's the 100. So now this is 173. And that is how a third grade student could show the solution to the problem they're pretty good with trying to estimate things and using their derived facts at this point. So base 10 blocks is a really good manipulative for them to show that, because they can't be taken apart. They would have to be traded out, and students would have to be able to use that knowledge in advance to be able to show this through the base 10 blocks. They would be able to use that knowledge prior to pulling out the base 10 blocks. So when students start to get into the 4th grade, they start to use this standard algorithm. They can also pair it with the base 10 blocks to be able to show the breaking apart of the blocks, the breaking apart of the numbers, and everything. So that's kind of what I'm going to do here with the 4th grade standards. So we're going to start with standard algorithm. 401 minus 228. So we know that 1 cannot take away 8, or 0 cannot take away 2. So we're going to have to break apart this 400. So 400 turns into 300 by canceling that out. This 100 right here, not the 400, the 100 right here, will now turn into 10 tens. So we're going to get 1 10, 2 10, 3 10, 4 10, 5 10, 10, 7 10, 8 tens, 9 tens, and there's now 10 tens, as you can see, 10 tens. So we're then going to take this 10 and add it here. Kind of add it right here. Well, this one can't take a 10, so we're going to turn it into a 9 because we need the 10 here. So this 10 turns into an 11 because of this extra 1. So now that we've broken up the 10s here with the 9s, these are going to break up into, well, not the whole 10s. Only one of the 10s is going to break up. So this 10 up here is going to turn into 10 ones. So I'm going to show you that. 1, 2, 3, 4, 5, 6, 7, 8. So now there's also 10 ones. So 11 minus 8. So what we're going to do is we're going to say 11 minus 8. So 11 minus 8. 1, 1, 2, 3, 4, 5, 6, 7, 8. There's 2 here, but there's also this one right here from the 401. So this is going to be 3. There's 3 here. In the ones place, there is 3. So now we're going to do 9 minus 2. Since we've already done most of the breaking part, this part is pretty simple. So 9 minus 2 is 7. And then 3 minus 2 is 1. And you're going to show this by saying, so the 9 minus 2, you'd say 9, 1, 2. And then these right here, so 1, 2, 3, 4, 5, 6, the group of 7 tens right here is what you are left with for this. So all of these. And then for the 300s, you're just going to say, so you're just going to cross out all of that. That didn't work out very well, but you know what I'm saying. There we go. So now you are left with this 100 right here. That is a 1. That is a 1. The 100 here. Then you are left with the 7 tens here and the 3 ones. And that is how you get the answer of 173.